Hello everyone, welcome to the next talk. This is about ScriptProtect. So I will be talking about mitigating unsafe third-party JavaScript practices. And I'm a PhD student from the Technical University of Brunswick. And this is joint work together with Marius Steffens, Sebastian Roth, Ben Stock, and all three of them from CISPA, and my advisor Martin Johns. So, yeah, sorry about it. Yeah, actually I totally forgot to add more on the slide. So never mind. It was an older version of the slides that I just converted to the OWASP template. Sorry about it. So, okay, I want to talk about third-party code. So this is more generically actually not about the web, but there was a general study about third-party code and some kind of open source security study. And they found that developers only write 10 to 20% of new code, and they heavily rely on third-party code. So I think it's kind of expected. You know, if you would start to write a website, you obviously would use some libraries. There's some popular stuff like jQuery out there, but also lots of other stuff. So you don't want to reinvent the wheel, so you just take what's available out there, and that's great. And as you can see on the slide, you would just integrate stuff from servers of other people. So you would maybe load jQuery from some CDN, and then you would load the ads from another server. And there might be also some analytics involved, and you usually don't host them just yourself, but it's actually loaded directly into your web page. So you just include a third-party script in there, and then it runs inside of your origin. And the way the same origin policy works is like very simple. You just include the script and then it runs in your origin. And this kind of sounds great from a development perspective because you get things done very quickly. But there are also some problems with this. So the thing is that third-party code then runs with full privileges. So basically it inherits the origin and then it can do whatever it wants. As a consequence, you can imagine if some popular library has a vulnerability that might affect many, many services at the same time. So this is a problem. And also, from our perspective, when we want to do something about that, this is now a bit more technical, but you have to remember that the inclusion of this code happens directly. So if you have in your HTML page a third-party script, then this is loaded no matter what. It's not possible like from that you have a script that actually inspects the requests first inside your page. So basically you can't prevent that script from being loaded. I mean, you could write some policies or stuff, but for as you will see later, for our implementation, that was kind of an issue. So you basically actually at runtime, you have no knowledge about what scripts are actually running in your page. You obviously define that during development time, but then at runtime, it's like, yeah, there might be scripts running, but who knows which scripts. So why is this an issue? Well, as developers, we control our own infrastructure. So our first-party code, we could do something. So for example, in a talk yesterday, we saw that you could use linters to basically look for unsafe assignments to something like inner HTML. And there's some other measurements you can take. You could have a secure development lifecycle, but that only works for the code that you control, right? So anything that you load from a third party, you have no idea what measurements they are taking to make the site more secure or not. So basically, you can control what APIs are using. You could say, for example, we have this rule, and you can't push code that uses in HTML in a kind of unsafe way. But yeah, for the third parties, that's not true. So let me quickly do hopefully a recap. Hopefully most of you are already kind of familiar with cross-site scripting. So, you know, it's a code injection. Basically, it's a very bad thing on the web because if you have that in your page, then an attacker can impersonate the users, can steal all the information and so on. So I guess we can all agree here that it's one of the main problems on the web. I just want to reiterate that, and even for very large companies, that's still a problem. So you might say that some company like Google, they do lots and lots of efforts actually, have lots and lots of rules in place to prevent that XSS gets into their page because they're a highly sensitive target, right? They don't want their Gmail users to be compromised. But still there are, it happens on Google also. So even they, who are very aware of that problem, they still, are not really able to prevent that at all times. Obviously, they also have a very large code base, but still it happens. So this was is a screenshot from a video from Live Overflow, which I can always recommend because he does great like write-ups in form of videos from CTFs. But in this case, he discusses quite recent XSS in Google.com and how it like works under the hood. So for this talk, I will only focus on the client-side version of the cross-site scripting. So basically, just to clear up some confusions, obviously all cross-site scripting happens on the client side, but in this case, the input is insecurely processed on the client side. So the effect is always on the client side, but in this case, also the processing. So it's nothing like the reflected XSS, the server-side reflected XSS that you might have heard about. So this is only the things that happen on the client, which we are focusing on in this talk. So the traditional example is something like document.write, where you would have, in this case, it's like a simplified example. You have some ad company that wants to add like an image to the page, which leaks the basically parts of the URL to their server. So it's might be used in some kind of tracking. And so some exploit could look like this, but there are some caveats, like the part of the fragment might be encoded, or does the script even trigger from the document, right? I don't want to go into details on this. It's just like how would it basically look like? So you just you close the image tag with this, actually might have a laser pointer here. So here we close the image tag, and then basically everything that comes afterwards is like controlled from the attacker now. Okay. So now this was basically the background of this talk. So what did we actually do? So we looked into the Alexa top 5,000 websites. We have this taint engine, which is now, since yesterday, I've heard, has been released publicly to GitHub. So you can also try stuff like that yourself now. And we checked, like I said, the 5,000 most popular websites, and yeah, we crawled them like up to 1,000 pages, basically sub pages on each of the sites. So we ended up with lots and lots of millions of pages, which we looked at. With this automated taint browser, and it's able to identify client-side cross-site scriptings basically automatically. And first of all, 99% of the sites had third-party resources, so that's great for us. And when we checked for the client-side cross-site scriptings, we found about 350 on those 5,000 sites. Obviously, we can't find all of them. The exploit generation might not automatically identify all the cases and stuff. So it's probably a lower bound here. And more interestingly, about a quarter of them actually were in third-party code, or more specifically, around a quarter of them were actually only vulnerable due to the third-party code. So we couldn't find any vulnerabilities in the code that they wrote themselves that was loaded from the first-party servers. But then they included some other stuff, and that was then actually vulnerable. So this is the thing we want to focus on. So can we prevent this specific case? So client-side, cross-site scripting caused by a third party. So this is where ScriptProtect comes into place. This is the name of our protection. So just to reiterate, our goal is to prevent the third parties from introducing client-side, cross-site scripting. And we wanted to do that in a way that we don't require browser modifications. So we wanted to basically create something that's easily usable and usable today. And so we don't rely on all the browser vendors agreeing on something and then implementing all of that and then needing to wait until all the critical mass of the users then updates to this new browser versions and so on. So we wanted to create this protection only in JavaScript. And as a result, basically, it's also easy to integrate and deploy. I will show a demo later, so you will see what I mean there. And to make the threat model clearer again, so we assume that the third party is not malicious. So if anyone would to overtake like a server of the third party scripts, where the third party scripts are coming from, then we can't really protect from that because these scripts are basically trusted by us. But what we do is we try to prevent the third parties from then adding additional scripts at runtime later on. So the initial script that's loaded from the server, I also have a slide on that. Yeah, so basically we strip the third parties of the ability to add additional JavaScript at runtime. And because that was not always clear, when I talked about this before, I added another slide to make the scenario even more explicit. So basically everything above that dashed line is the first party. And as you can see, we load resources from the third party. So imagine a script with a source attribute, where there's stuff pointing to our own servers. And then later on, so this other icons, basically these happen later on at runtime. And basically later on, we want to decide, yeah, we need to like assign the inner HTML and want to add an image. And we also want to add some JavaScript dynamically. So the image is fine, right? So we assume an image without like event handlers or stuff. So just a static resource, which does not execute code. And then, well, if we want to add further script at runtime, that's where it might get problematic, right? So at this point, this could be caused by an attacker in a form of a client-side cross-site scripting, or it could actually be intentional because we want to add further scripts at runtime ourselves. But it's really hard to tell at this point. So here the question is, do we want to allow that or not? And it's basically your decision. So in our protection, you can also like specify if you want to allow this case or not. So you could say like, okay, I trust my own code enough that I know if I add further code at runtime, this is going to be safe. Or if you would rather like also block these cases. So that's why I added this in yellow. So it's like undecidable, or depends on your use case, right? And then, but also this is not the only stuff on your web page. So we also have resources from the third party. And like I said, if they are specified in the initial document, then these obviously are going to be loaded. So we don't prevent like so we don't disable all the ads and the trackers and everything you might need. This still is loading fine. But then if the third party scripts now, they also decide like, let's add some images and some further scripts. And for the image, again, we say, okay, that's all fine. But for the JavaScript that's added at runtime and that addition is initiated by a third party script, that's where the protection really kicks in. So this is always blocked by our protection mechanism. And the other case, you decide if you want that or not. Okay, so how does it work? The way it works, it's you add a special script at the very top of your document. And this will be loaded first, so we can basically set up the stage in a way that all further script additions will first be audited by us, and then we decide or the protection mechanism we designed decides if that's an allowable case or not. So it wraps all the dangerous things, or APIs, something like document write, inner HTML, and lots of other stuff. And then it will, like I described, will allow benign content, that is content that's not like actively executable, something like a link or an image or whatever. And well, there were some challenges with that. So the question is like, how do you instrument all these things without actually breaking down functionality that they want to expose? And also, how do you differentiate between the different parties? And what happens with so parties like third party, first party, and what happens with libraries like jQuery? Is jQuery the first party or the third party, or is it somewhere in between? Because you might imagine that both the first party and the third party, they use jQuery, and then later on that jQuery actually adds the script. So at best, you would just ignore all the libraries from that decision, because you can't really decide like where they are. So this is just a collection. I mean, the list is much longer. It just didn't. I would need at least 3 slides to show all of them. It's more about that there are so many different APIs that could introduce further script content, and they are also different in nature. So some of these, like as you can see, some of these might be properties. So for inner HTML, you take like an element, and then it's a property of that element. But in other cases, it's just like a global API, like the function constructor or something like set timeout. So there are many different cases, and some of these also take HTML, for example, and then others take JavaScript. And there's even the set attribute, which could, depending on which attribute they're setting, could be all 3 of them, like the URI also. So there's lots of different things that you have to worry about, but let's say we did the heavy lifting there. So the ScriptProtect.js considers all these cases and the cases that didn't fit onto the slide and instruments all of them. So I'm just showing one example. Here really a simplified example on how this basically works under the hood in case you're interested, how the protection works. It's not really important if you just want to use it, but still might be nice to know how this actually is implemented. So in this case, we have the original inner HTML, which we take from the prototype of all the elements. So basically, we want to change it for all the elements in the page, right? So that everything is affected, and we redefine that. So what basically happens then is every time you call inner HTML on any element on the page, it would just first go through a sanitization step, which we control, and then it would do the old thing. So afterwards, with the sanitized value, it would call the original inner HTML. And I will also come back to that later, but let me say here, this obviously is not secure in the sense of sandboxing, right? So if you have already a script in the page, then you could just call like the old variable here. So this is why we don't protect from a malicious third party and only from the client-side, crowd-side scripting that are dynamically added to the page. Okay, so to the sanitization, this is out of scope for us, so we just use DOM Purify. You might have heard that name before in one of the previous talks. It's used a lot, and yeah, it also does a fine job for our use case. So why is this cool? Well, now it's basically secure by default. So if you call inner HTML, it will be sanitized in all the cases. So you don't have to refactor your own code. You would just add that script at the very top, and it gets executed and changes the way the inner HTML works. And then you basically prevent the introduction of new code at runtime. So how would you integrate that into an existing or into a new application or into an existing application? It's a bit different. So if you have a new application and you're starting from scratch, which we don't expect you to do, but that's also an option, then you could, yep, I know. It's happening. Okay, don't touch. Okay, I try not to touch it and then it will hopefully stay. So if you're writing a new application and you need that functionality, like you actually want to add scripts, right? There might be a valid use case where you say, okay, I've audited that code and actually at this point, I'm really sure what I'm doing. So I just want to like add scripts like I'm used to, right? So then you could call, something like an unsafe write. So we would expose, functionality that would like be able to circumvent the protection, right? So what's also great about that, it's very explicit, right? So if you have to audit the web application, then you could basically skip all the hopefully lots and lots of normal document writes, which you know are safe, and you could just focus on the unsafe write. But like I said, you wouldn't be able to do that with existing applications, right? Because they are not aware of this. I didn't even touch it. I just try to keep on and we hope it stays. Yeah, the thing usually goes away after a while. Okay. Why doesn't it go away? Cool. So for legacy applications, so you have an existing web application that you basically you don't want to change much. You just want to add this protection, right? You don't want to do a lot of work. So what we do here is dynamic access control. So we inspect the stack trace, which is actually available in JavaScript at runtime. So what you would do is something like you throw an arrow and you immediately catch it, and that way you get the stack trace. So as you can see here, from the stack trace you could see. No, that was a mistake. The problem is I need to touch my laptop because otherwise I can't go to the next slide.
That part is connection to the record
now. Oh, okay. We could try it. I mean, I'm not sure if it's the touching because sometimes it just randomly switches off. Yep. Yeah, I know. Just accept this random USB stick from somebody in the audience of a security conference and you're fine. Also, it wants to be a keyboard. What could go wrong? Hopefully. Well, okay. So maybe if I don't touch... Yeah, the thing usually goes away after a while. Because if I touch it again, then we're screwed. But also I want to show a demo in 2 slides, but you can imagine that will involve some problem. Oh. Was it because he was... Okay, I think it's sufficiently dead now. Okay. Yeah. Dynamic access control. So this is just how we implemented it. Cool, right? So as I told you, we have this arrow which we catch again. Or we never throw it. We just create an arrow and then we read the stack trace. And this way we basically can compare if the top of the stack, so the very first thing, the very first script that initiated all this action, if it is the same as the current page. So basically we can see if a first party script or a third party script initiated some action. Yeah, I don't think so either. And well, this allows us to also selectively whitelist third parties. So you could say we trust this random third party a lot more than all the others. Maybe it's like you have an agreement with something with them, or I don't know, you audited them or whatever. So there could be some cases where you say, okay, we want to allow our own page and this special third party to add scripts, but nobody else. So that's also possible. And this is a point where the demo is coming, and this might be problematic. Yep, that's great. Yeah. Okay, so I've set up a very simple web page, and let me show you the source. So we obviously depend on DOM Purify, and we depend on our own protection, which is called Protect.js. And it has some, I won't show you the whole course. It's just, it has some things that you can configure. So you could say, don't do the full protection, only report the things that we do not block. And then you could add your own logger instead of logging to console, what I'm doing currently. But anyway, so there are a few options that you could configure here. You could say some stuff is just benign, just allow that because it can't harm us. And what else do we have? So we have a first party script and a third party script. So the third party is coming from, it's just redirecting to localhost. Maybe I just keep going and whatever. Maybe you take a photo each time it's on and then I just continue talking, and that might work well. So the first and the third party basically just add images. In one case, an image without any event handlers, and in the other case, an image with an event handler. So let's see what happens there. So first of all, I add this image, and yeah, everything's fine. Then I add the image with the event handler, and it gives me just an alert as an example that we have obviously code execution. Things are starting to jump around. So both of these events were initiated by the first party script, and that's why it basically was allowed. And if we do it for the third party, so the events of the buttons were bound from a third party in this case. which you can't see now, but just have to trust me, that's the case. And so the image is inserted normally. And if we add the image with the event handler, it's also inserted. So that part is basically still allowed, but the alert did not trigger because we sanitized the values first. So as you can see here on the console, it says blocked, and the initial, like, we wanted to add this code with the onload alert, and but we then actually removed from the image the onload attribute because that was basically done by don't-purify this step. And here you can also see the stack trace, and you can see it like the lowest entry is like who actually initiated, and then it goes on to the top. So in this case, it was initiated by the third party. So that's why it was blocked. Yeah, we just have 5 more slides, so we might be able to pull this off. Okay, so if you do something like that, you always obviously have to like measure does it affect the browser and does it affect the website. So first of all, we checked, so how much impact does it have? So for one, the site will obviously load a little bit slower because you have to load this, in this case, 19 kilobytes of minified JavaScript first. And most of that is actually due to don't-purify. So our protection script is only about 5 kilobytes. And I've heard about some plans that the browsers want to implement a native sanitizer. So in this case, we wouldn't have to depend on this library anymore because there's just a sanitization functionality built into the browser, which we could directly call into once enough clients actually have that rolled out. And then maybe use don't-purify only as a fallback for older clients. Also, it slows down the web page a little bit because all of this rewriting and like additional checks and stuff. So in this case, we just tested it with 50 random websites that obviously use third-party scripts. And it was about like 6% slower or something on average, but it's hard to tell, especially for websites that are rather slow anyways. Yes, and as I said, not only the size would be smaller, but also native sanitizer written in C++ should also be faster than the JavaScript sanitizer currently we are using. So like there's room for improvement there. And looking into compatibility, so we had about 4,500 of the initial 5,000 websites, which are actually like crawled successfully, and most of them also had third-party scripts, like I was saying. And I can't even see the slides on my own. Okay, so the problem was that many of these websites were actually doing the very thing that we wanted to prevent. So they, for example, 94% of the websites had a third-party script that wanted to add something with URI sync. So imagine a script with a source attribute. They wanted to do that at runtime, and we wanted to prevent them to do that because it's an unsafe pattern. But they did it anyway. So that's kind of a problem if you want to be compatible with existing websites without any changes. Because changes of third-party code are especially hard. Like I told you, you are not in control of them. So, I mean, if you are using that thing, then you can say, okay, maybe I rewrite my code, but for a third party, you need to contact them, and I'm not sure if they care, right? Yeah, so this is a problem, right? For HTML things, like document write with just an image tag, like I showed you, it was luckily only 70%, and for something like dynamic editions of JavaScript, it was even less. Yeah. So what did we do? Well, we looked back into the initial vulnerabilities that I showed you in the first place. So we had these 129 cross-site scriptings that were caused by third-party code. And we investigated them and we realized, okay, basically all of them, except for 8 of them. And if you're confused why it's 130, if you sum it up, that's because of one of the websites was actually, like the 129 was only the overall count, but the 130 was because one of the websites had two of different kinds of things. So anyways, the 8 websites that didn't have an HTML sync were the exception, and 122 actually had all the cross-site scriptings because they added HTML dynamically at runtime. So if you remember now the slide that showed you before, then combine it with that slide, we came up with the idea. So, okay, maybe for backwards compatibility, we just wrap the HTML things. So that means about 30% of the websites that were so that's like the counterpart of this 70% that did use HTML. So basically, the counterpart to here. Here we had 70% that use it, so that means 30% don't use it. And on the other hand, we still get, we can block 90% of the cross-site scriptings that we found in this case. So it's like this trade-off of, okay, so we don't wrap some of the things, but on the other hand, it means that a lot more websites just can use it without any adoptions. But it doesn't catch all the cases anymore. So it's a trade-off. And like you could argue, do I want to be 90% secure or do I want to be 100% secure? At least from like this specific, obviously never 100%. But for this specific attack, but I think there's a place for some protections that just, maybe they don't catch all the types, but at least they are just initially, like immediately usable, instead of nobody ever using it because it's too complicated to set up. I don't want to call any names here, but there were some security approaches that just weren't adopted because they were too complicated. So we tried a different approach, and we know that it doesn't catch all the cases, but on the other hand, it just like kind of works out of the box because without you changing lots of stuff. So just as a quick comparison, you might know there's some other stuff out there like content security policy. And for the 129 vulnerable websites, we found that all of them used inline scripts or event handlers, so they had to deploy an insecure content security policy. And if they want to use a secure policy, they would again need to rewrite the application. That's basically the very same thing we wanted to not have as a requirement for our protection. So that's why in this case, a CSP didn't help much. And you might also heard about this trusted type thingy going on. It's a proposal to eradicate client-side cross-site scripting. But in this case, also, the problem is that you don't have control over the third party. And if the third party doesn't use the trusted types, you might run into a problem there. So you don't have control over that. And basically, that's another reason why you would rather try it like this, like we've done. Not to say that it's like perfect or something. So we ran into some issues, obviously. So one of the things was just due to our study. So you might remember we visited about 1,000 websites, 1,000 subpages of each website. So there might be just a case that we missed. So we thought this website was compatible, but we actually missed the one specific subpage that they had that actually wasn't the case. So that might have happened. Also, just because of the implementation that we did in JavaScript, we could not wrap the eval statement for some very specific reasons why it would then lead to different results if you eval code afterwards and depend on some variables that you defined before. And also, the trend is to use more asynchronous like commands or functions. And in this case, in some particular cases, we also can't rely on the stack trace anymore like we did. So for this, we would actually need a native, for the eval and the stack traces, we would actually need a native implementation into the browser and could not deploy it in this JavaScript way that we did. And to say it again, we are not protecting against malicious third parties. But it's not really a limitation. I just added it here because it fits. Is rather out of scope. So we never wanted it to do that in the first place. It's just not in our tech model. So as the summary, we have this reliable protection against third-party vulnerabilities, and we think it's easy to deploy because you just add that protection script at the very top of your document. And especially compared to competing approaches, we thought about how can we make this backwards compatible with existing applications without requiring code changes. And also it's a compromise between compatibility and security. And if you want, you can try it yourself. It's on github.com/scriptprotect/scriptprotect because we had to submit it anonymously to get the paper out there. And yeah, I can try to answer your question now, or as always, you can also write me later on via mail or Twitter. Yeah, thanks.
All right, thank you, Marius. Are there any questions so far? All right, there's number one.
If I understand correctly, you're wrapping like the element methods like inner HTML when loading the script. So how do you deal with dynamic entries from a first-party script? Say, let's say the first-party script adds a DOM node after first render. I'm not going to even try to. So what I'm doing is, so one of the things that's important, that's the very first script, is that is executed as our script, so that it's basically nobody can do things before, right? And the other thing is, I'm overwriting the inner HTML functionality on the prototype of the element. So the element is basically the parent of all the DOM elements and HTML elements and whatever. So everybody inherits that change. And also because it's a prototype, it will be, it will affect all current and future, basically instantiations of one of the elements. So this is how we handle that.
All right, are there any other questions? Well, okay, I do have one. If a third party would themselves override one of the prototype or elements for some reason, how would that affect your ScriptProtect?
That's basically out of scope for us. So if the third party does try to circumvent it intentionally, that's what I've excluded. And if they do it accidentally, that's kind of unfortunate, but would require like heavy monitoring on our side, like checking if the protection is still in place. I don't think that's all too practical, because it's just like not considered in this case. So the third party has to behave properly as we expect it to, because the idea was you include a script from a third party in the first place means that you trust them somewhat, right? So if you don't trust them, then please don't include that script in the first place. But we are not entirely sure if they are doing things right. So if they have proper security measurements in place. So the term that we actually used in the paper was benign but buggy. So they don't try to circumvent our protection, but they are also like maybe not properly doing things.
All right, thank you. Any other questions here? Yes, okay.
Just a quick one. Looks like a very interesting project. So I think it should be an OWASP project. Why don't you make it an OWASP donated to OWASP? Then you'll have lots more contributors and help you out to bring it to the next level.
Okay, yeah, we can try that. So if you know the proper people to talk to, I'll be around today till the closing. So yeah. Thanks for the suggestion.
Other questions? Going once, going twice. Thank you. Thank you very much.